Hello, my name is Tripti Tomar. I'm a first year MCA student in KIT Group of Institution. The topic of my lecture is RISC and CISC. First of all, what is CISC? CISC is an acronym for Complex Instruction Set Computer and are chips that are easy to program and which make efficient use of memory. Since the earliest machines were programmed in assembly language and memory was slow and expensive, the CISC philosophy made sense. Most common microprocessor designs such as Intel 80x86 and Motorola 86K series followed the CISC philosophy. But recent changes in software and hardware technology have forced a re-examination of CISC, and many modern CISC processors are hybrids, implementing many RISC principles. CISC was developed to make compiler development simpler. It shifts most of the burden of the generating machine instructions to the processor. For example, instead of having to make a compiler write long machine instructions to calculate a square root, a CISC processor would have a built-in ability to do this. Now, what are the characteristics of CISC? Complex instruction decoding logic, driven by the need for a single instruction to support multiple addressing modes. A small number of general purpose registers. This is the direct result of having instructions which can operate directly on memory and a limited amount of chip space not dedicated to instruction decoding, execution, and microcode storage. Several special purpose registers. Many CTSC designs set aside special registers for stack pointing, interrupt handling, and so on. This can simplify the hardware design somewhat at the expense of making the instruction code more complex. A condition code register, which is set as a side effect of most instructions. This register reflects whether the result of the last operation is less than, equal to, or greater than 0 and records if certain error condition occurs. Now, what is RISC? RISC, a reduced instruction set compiler, is a type of microprocessor architecture that utilizes a small, highly optimized set of instructions rather than a more specialized set of instructions often found in other types of architectures. The history of RISC is that the first RISC project came from IBM, Stanford, and UC Berkeley in the late 70s and the early 80s. The IBM 801, Stanford MIPS, and Berkeley RISC 1 and 2 were all designed with a similar philosophy, which has become known as RISC. Certain design features have been characteristic of most of the RISC processor. First of all, one cycle execution time. RISC processors have CPI, that is clock per instruction, of one cycle. This is due to the optimization of each instructions on the CPU and a technique called pipelining. Now, what is pipelining? A technique that allows for simultaneous instruction of part or stages of instructions to more efficiently process instructions. Large number of registers. The register design philosophy generally incorporates a large number of registers to prevent in large amount of interaction with memory. The main characteristics of CISC microprocessor are extensive instructions, complex and efficient machine instructions, microencoding of machine instructions, extensive addressing capabilities of memory operations, relatively few registers. Whereas the characteristics of RISC processor are more or less the opposite, such as reduced instruction set, less complex simple instructions, hardwired control unit and machine instructions, few addressing schemes for memory operands with only two basic instructions, load and store. Many symmetric registers which are organized into a register file. Now, what is the difference between RISC and CISC? CISC emphasizing on hardware, whereas RISC emphasizing on software. CISC includes multi-clock complex instruction, whereas RISC includes single clock reduced instruction only. CISC is memory to memory, load and store incorporated in instructions, whereas RISC is register to register, load and store are independent instructions. CISC have a small code size and high cycles per second, whereas RISC has low cycles per second and large code size. Transistors are used for storing complex instructions in CISC, whereas RISC spends more transistors on memory registers. Thank you, everyone. These were the most important points about RISC and CISC. Thank you.